Today I want to make a video about how we can um, synchronize different locations in Git and with respect to each other. For example, we have a working tree. Um, then, as you know, we have three. Actually, we have four locations when we work with the Git. The first is working tree. The second is okay. I just want to make the exact rectangle, working tree, and one more, actually two more. I think it would be better if I did it like this. Yeah, let's do it like this. And one more. Okay. And let's delete that working tree from here. And let's write it here. As you know, we had four locations in the Git system. The first location is the working tree. Working tree. The second is the stage area. The third location is local repository. And the last one is the remote repository. Let's just write it repo. All right. The first case is the working tree is your file system. It's the files that you see on your workbench when you work in Visual Studio. As an example, for example, let's say you work on the project called Python Essentials. This is your working tree in this area. And yeah, I just wanted to put those windows side by side. So working tree, let's say you have made a change in the working tree. You changed a content of the file, or you added a new file to the working tree. And what you want to do, you want to synchronize the stage area with your working tree. You want the staging area to be as same as your working tree. Or you can do it by just adding all of the changes with git add command. Git add. Or you can specify a single file, git add, the file name here, file name. What it does, it synchronizes the stage area with respect to the working tree. What it means is that you have a change in your working tree and you want staging area to be the same as the working tree, not vice versa. Because for vice versa, we have another command. So this is called git add for all of the changes that you can make. You have made. You can add all of those changes to this staging area with one command called git add dot. The second one is git add file. You specify a file. You just want to add that file to the staging area. You want to synchronize that file in staging area with respect to the working tree. And let's do that. Let's do that. Okay, as you see here, exception handling file. Let's first see the difference? Is there a difference between the staging area and the working tree? And how did we do it? It's here. Git diff. Yes, we just write git diff command, and we'll see all of the changes, all of the difference between the working tree and the staging area. So I just wanted to make sure that when we start showing example, everything is synchronized, everything is same as in staging area and the working directory. So I just wanted to make sure if there's a change in that between those locations, I will synchronize them. So let's see. Git add. Oh, sorry, git diff. Okay. There seems to be a change. And now we can get rid of that change just by synchronizing the staging area with respect to the working tree. We can do it for, as I told you before, for a specific file, or we can do it for the entire project. Okay. Let's do it. Git add. Let's just add all of the changes to the staging area. Okay, now let's see if there's a difference. Yeah, there's no difference. There is no difference. Now, as I explained you before, when we make a change in a file, for example, it's called exception handling. We, for example, add a comment, change to. Change to. And if we do git difference, there is a change. The stage area and the working tree, they're not the same. We can just write git add. What it does, it synchronizes staging area with respect to working tree. Git add. Okay, now there is no difference. Okay, what else? What else? So let's go back here. So we look at the example like it. So we did this command here, and I'm drawing this arrow in this direction because in our working directory nothing changes. All of the change is happening inside the staging area, but I think it might be a little bit confusing. So what I'm doing here, I will change the direction of the row. It means that it synchronizes the staging area with respect to the working tree. So it looks at the working tree and it makes sure that the staging area is same as the working tree. If it specifies a file, it will check whether it will make sure that the file was specified is the same in staging area and the working tree. If we just add, if we just do git add specify file, if we just do git add dot, it will make sure that the content of the project in staging area is the same as the working tree. So git add for entire project, git add file specify. Okay, we did it. Now let's look at this direction. This is interesting. So in this case, in the first case, we made sure that the content of the staging area is the same as the working tree. But right now, what we want to do, we want to make sure that the content of the working tree is same as the staging area, like exactly the opposite. And I will give you an example. Let's say we have made a change, like let's say change 3. change 3, and then we add that to staging area. Git add, yeah, we added. Now we're going to delete this. We're going to delete this comment. And right now, the content of the working tree is different than the staging area, because in the staging area, the change 3 exists, but in working tree, I just deleted that change so we don't see it. So the content is different. In order to make sure that the content of the working tree is the same as the staging area, we can also do it for the entire project or for a specific file. We use git restore the file specified. And in this case, it's exception handling exception handling.py. Yes, you see the change 3 comment is now back. What we did here, we made sure, again, I just want to repeat it again and again to make you understand and help you wrap your head around this concept. We made sure that the content of the working tree is same as the staging area for this file. But in the first case, we made sure that the content of the staging area is the same as the working tree. Now, I just wanted to try something. I want to use git restore for the entire project, but I think it's not possible. We have to specify a file path for git restore. And let's do it. For example, change 4, and we add git add, and now let's do git and let's delete this to make sure that the contents are different. And now we'll git restore. Yeah, you must specify paths to restore. Okay. Git restore exception handling .py exception handling. Oh, sorry, exception handling / exception handling .py. Now we see the change 4 back. So what if we want to do for the entire project? I think in that case we should use git reset. So you see git reset unstage everything. It's not what we want. We'll talk about it later. It in other words, match the stage with the last commit. It's not what we want. Git reset hard, match the working directory with the repo. It's not what we want. Git restore file name, match the file from the staged area. Git restore. What if we do that? Specify path restore. Okay, let's ask this to ChatGPT. I'm not sure if it's possible or not. Let's see. If it is possible to match your entire project in the working directory with the staging area. Staging area. Use case is you have added files to this. Okay, let's say you have changed the content of multiple files, then you added them to the staging area, but now you undid those changes in your working directory, and you want now your working directory be the same as the staging area. Is there a command to do it for all of the files? Okay, let's see. Yeah, but no. Oh, interesting. I didn't know about this command. Let's see. Let's try to use it. So let's make change for multiple files. Okay, change for here, and let's do change for here is okay. Import numpy from as np print I am change 5. And let's also add this to the staging area. Hit add. And now let's delete this. And now we want to use a single command to synchronize the working tree with the staging area. We want the entire content of the working tree to be the same as the staging area. And let's use the method that git restore work tree. Okay, git restore work tree. You must specify a path. Oh, okay, git restore. Maybe this. Oh, okay, change 5. Oh, it seems working, and we see change 4 here. Okay, let's try it again. Change 5 and change 5 here again. Now let's add them to the staging area. And now let's delete them. Okay, change 5 and change 5 here. And let's see if it works for both files. Okay, git restore, change 5 here, change 5 here. We found what we really wanted to do. Okay, so for a single file, we use git restore, and for multiple files we use git restore and we add dot here. Okay. So let's talk about the other stages. So the next thing is we want to make sure that the content of the local repository is the same as the staging area, And in that case, we don't need to specify whether for a single file or for a multiple file, because we already specified it in this stage when we did git add dot or git add. If we did it for a single file, and when we do this process of synchronizing the local repository with respect to the stage area, then it will do it for a single file. If we did it in this stage here for the entire project, then it will do it for the entire project in this stage as well. And how we do it, first let's look at the example. I want to see the difference between the stage area and the local repository. Stage area and the local repository. Okay. Let's see it. Here, we see it. Repository and the stage. Git difference cached. We use that. So of course there will be a difference because we never added those changes to the local repository. Let's see. Here. Git diff cached. Yeah, a lot of changes. Now let's make sure that they're synchronized in a way that I told you. We do git commit .m. Let's say change. Oh, before I just wanted to add them to the staging area, all of the changes, right? Yes. Git add. Is there a difference right now? No, there's no difference. So git. There's no difference between the working tray and the staging area. They're the same. And right now, I just wanted to make sure, is there a difference between the staging area and the local repository? Because we never committed those changes to the local repository. They just only exist in the staging area. That's why there's a difference. Yeah, okay. Let's do it. Git commit. Sorry. Changes added. Yeah, 2 files changed, 17 insertions, 2 deletions. And now let's see, is there a difference between the repo and the staging area? Git difference cached. There's no difference. Also, there shouldn't be any difference between the working tree and the repository. Oh, sorry, git diff head. Oh, I'm really sorry. What is it? Git diff head. I just need to write git diff head. Yeah, there's no difference. All these locations are synchronized with each other. So let's go back here. Let's go back here. So git commit. And commit message here. Like you give the description of what you have done, what you have changed. So, and the vice versa. Oh, sorry. The vice versa. What is the vice versa? The vice versa is that we want the staging area to be the same as the local repository. In the previous example, we wanted the local repository to be same as the staging area, but now what we want to do, we want the staging area to be the same as the local repository. And let's do that. How do we do it? Git reset on stage. Git reset. In other words, match the stage with the last commit. And I will give you a use case. I will create a scenario where the stage area is different than the local repository. Okay, first we want to change something from the staging area. We want to synchronize the staging area with the working directory with git restore. For example, let's say we have a we delete this change 5 and we want the staging area to be the same as working directory. Okay, let's do it now. Let's do git add, right? Git add. Okay, now I want to, so as you know, I added a new change to, I deleted that change 5 comment, and now I added that change to the staging area. Right now, there is a difference between the staging area and the local repository. And we can take a look at that. We can just write git diff cached. Yeah, there's a difference. Change 4. And now if we do git reset, it will add that change 5 to the staging area. Working tree, there is no change 5 comment. We don't synchronize anything with working tree. We want to synchronize the staging area with the local repository. Because as you can remember, we committed those changes to the local repository. Especially, I'm talking about the change 5 comment. And now git reset. And what does git reset do here? Unstage everything. In other words, match the stage with the last commit. And the last commit is the commit that the local repository, the branch in the local repository is pointing to. And git reset. And now the staging area. First, what I want to do, I want to synchronize the staging area with the local repository. Then I will synchronize the working tree with this stage area. Okay, let's do it. Git reset. Okay, unstate changes after reset. So right now, we have that change 5 in our Git storage area, and now now we want to make sure the content of the working tree is the same as the stage area. And how do we do it? We just do it with git restore. Now we will see the change 5. Now, as you see here, it works as expected. So, local repository, it will be git reset. Git reset. Local repository, in the case of git reset, still points to the same object, but now the the stage area does not points to the same commit, right? Yes, this is what we wanted to do. Let's look at the other examples of Git. Uh, Git restore. Oh, we already talked about it. Um, Git reset hard. Match the working directory with the repository. Um, what we did here was actually Git uh, reset hard. Git reset hard. Uh, we uh, made sure that the content of the working tree is the same uh, as the local repository. Now we will do it in one command. The same thing. For example, let's say we have change 5. We delete. Okay, they're the same, change 5, and we delete it. And that change, you know, it already exists in the repository, local repository. What we do, we look git reset hard. Yeah. Now there's no difference between the stages, as you can see. Yeah, there's no difference. So with git reset hard, with just one command, we can do what we did previously with the help of git reset and git restore. So what we learned that with just git reset hard, we can it's just a combination of git reset and git restore. Git restore. Okay. So git. Oh, actually, it's like this. It makes sure that the content of the working tree is the same as remote local repository. Sorry, local repository. Git reset hard. Okay, one thing is left is we made sure that the content of the working tree is same as local repository, and now the last thing we want to do is we want to make sure that the content of the local repository is same as the working tree. Yeah. And how do we do it? I'm also curious. Mm-hmm. It's also interesting. Let's see. How can I make sure that the content of my local repository is the same as working tree, not the opposite? Okay. Mm-hmm. Okay. It's interesting. It's just a simple. As you see, it's interesting. We learn that there is no a direct way of doing it. It's just the combination of git add and git commit. So git add, git commit. We make sure that the content of the local repository is the same as the working tree. Okay, I'm leaving this part, the remote repository, for the next video.